This video is about potentiometers. It corresponds to section 5.1.3 of the Applied Analog Electronics textbook. All of these devices are potentiometers, and as you can see, they vary considerably in size. Potentiometers always have some part of them that is adjustable. These ones with the large shafts here have a knob that you can turn. These little ones have a slot for a screwdriver. And the two different types, they're all potentiometers. But when you have just a tiny little screwdriver adjustment on them, they're usually referred to as trim pots. And pot is a common abbreviation for potentiometer. And a trim pot is usually adjusted to make a circuit work correctly and then left alone. Whereas these larger ones are used as control knobs where human input is used to adjust the behavior of the circuit. Now, all the potentiometers are 3-terminal devices. And we draw them with this symbol here, a resistor and then an arrow touching the resistor to go out to the third terminal. And if you take a look, you can see that several of these have got 3 wires connecting to them. Now, there are times when we get slightly different controls. For instance, this one has got 2 potentiometers on the same shaft, so that it has 2 of these hooked up together mechanically. This one has got, in addition to the 3 terminals for the potentiometer, has 2 more terminals for a switch. And at one end of the run here, the switch is there, and then continuous turn for the potentiometer after that. And that's often used for something like an on-off control with a volume control, so that when you turn it on, it's at minimum volume, and then as you turn it up, you get larger volume. We're not going to be using these fancier ones, the ones where we have 2 different controls on the same shaft. We will use, however, controls like this one or this one for adjusting values in our circuits. Now, this schematic here, the symbol for it, is intended to be very indicative of what the thing does, because what we've got here is a voltage divider. But the voltage divider is not a fixed upper resistance and lower resistance. We have a resistance here which is the sum of those, and this arrow is a wiper arm that moves back and forth on the resistor to make any of the possible combinations of RU and RD that sum up like this. If you took apart one of these internally, you would see a resistor that's a circular arc, usually 3/4 or more of a circle, and then you would see on that a wiper arm that came to the middle terminal here, and as you rotate this wiper arm, it makes contact anywhere from A at one end to B at the other end. Now, obviously it matters which end is which, because clockwise you're connected to one end, counterclockwise you're connected to the other one. So it's usual on schematic diagrams when you're doing a potentiometer to indicate which end is the clockwise end by writing a little CW next to it. And then when you turn the knob or the screw all the way clockwise, you're connected to this terminal. When you turn it all the way counterclockwise, you're connected to this terminal, and for intermediate ones, you're somewhere in between. And we'll use these things as adjustable voltage dividers. There are times when you want just an adjustable resistor and not on a full adjustable voltage divider, and there's a little trick for doing that. First of all, don't ever draw a schematic that looks like this with the wiper arm unconnected, because there you just have a fixed resistor. The wiper arm, if it's not connected, isn't doing anything. So don't do that. If you want to indicate that you're going to use this just as a variable resistor, there's two ways to do it. One is to have these two terminals as the ones you're using and write a little NC next to the other terminal to say it's not connected. And then you've just got, well, if this is the clockwise end, when you're clockwise you have zero resistance, and when you're counterclockwise you have maximum resistance. And you could, of course, have picked the clockwise end to be the non-connected one, either one, depending which way, whether you want clockwise to increase or decrease your resistance. The other way to do it is to connect the wiper arm to one of the ends. And now when you're connected to this end, you'll have the full resistance between the two terminals. When you're connected to the top, you'll have zero resistance. So it's the same circuit as the one up here as far as the behavior is concerned, but you no longer have to indicate that something is not connected because you've connected it. Basically, the RD resistor here has been shorted out with a wire, so all you have is that variable RU resistor. So that's the way to do variable resistance with a potentiometer, and we'll do that occasionally, but more often we'll be using it as a full voltage divider and having all three terminals connected. Okay, that's probably all you need to know about potentiometers for now. You should probably practice a little bit in figuring out what you can do with them.